Hi, good morning, everybody. We are now up at the top of page 13. So on example 3, we are going to use 6 rectangles to approximate the area under the curve for the function f of x equals x minus 4 squared plus 5. So we've got ourselves a quadratic with a vertex at 4, 5, and then on the interval 3, 6. So the first thing we want to do is break up our interval using the number of rectangles given. So I like to go ahead and darken the function itself. So the interval is from 3 to 6. So here's 0, here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. So that's the interval I'm going to be finding the area under the curve for. Now remember, if we can make each of the bases of our rectangle be 1 unit long, that's going to be the easiest way of doing these problems. But sometimes you're going to have to break up into half units for the bases in order to make the number of rectangles work. So if I look on this interval, if I made each of the bases of the rectangles be equal to 1, I would be able to make 1, 2, 3 rectangles. So I can make 3 rectangles. I need 6 rectangles. So what this tells me is that my base is going to have to be 0.5. So I'm going to go ahead and break this up into smaller intervals. So there's 3.5, there's 4.5, and there's 5.5. And again, I like to label those little tick marks just because I think it makes designating the rectangle heights later a little bit easier. So next, our height of each of our rectangles will come from that function itself. And folks, I almost forgot about that plus 5 on the end. That's a really common mistake to make on the homework as well, so make sure you've got that there. So f of x equals x minus 4 squared plus 5. So that is what we can type in on our calculator into our y equals and use to find our heights. So folks, on this problem, we are only going to be finding the LRAM. So only drawing the LRAM on this one. So what we need to do is multiply each of the bases times each of the heights, and our base is going to be 0.5 every single time. And I'm going to go ahead and multiply that by the sum of the heights. So let's go ahead and draw our rectangles so we can calculate our LRAM. So we're going to extend up from that starting interval. Draw a dot on the function. Extend up, dot on the function. Extend up, dot on the function. Extend up, dot on the function. Alrighty. So remember, that's how we start our graph, whether we are finding LRAM or RRAM. And now to find LRAM, we're going to start at the leftmost point and start drawing our heights. So let's go ahead and start at this leftmost point, draw our height, and then color down. Next point, draw our height, color down. And draw our height, color down. This is our height, color down. This is our height, color down. And then this is our height. So notice on the left part of the quadratic, our rectangles are above it, and on the right part, our rectangles are below it. So folks, when you're checking your homework over this, make sure you're checking how you draw the image very, very carefully. Make sure your rectangles are hanging over in the right spots and hanging out under in the right spots. So now that we have drawn our LRAM, we are ready to calculate LRAM. So our first height would be f of 3. This is our first height, so f of 3 will give me that height, and it looks like it is maybe at 4, but I guess we'll find out once we start working through this problem. So we've got f of 3 plus our next rectangle height comes from f of 3.5. Our next rectangle height, f of 4, f of 4.5, oop, f of 5, and f of 5.5. Are we going to include f of 6? No, because that dot is not the height of any rectangle. So make sure you don't include the extra endpoint when you're calculating either LRAM or RRAM. So now we can use our calculator to evaluate our function at each of those values. Now, you can use the trace button or you can use the table. I'm going to go ahead and demonstrate using the trace button, so that we don't have to go by half intervals on our table. So let's go ahead and do trace 3. That gives me 6. 3.5 gives me 5.25. That would be helpful if you guys could see that. Yeah, 5.25. And then f of 4 gives me 5. F of 4.5 gives me 5.25. And then f of 5 gives me 6. And f of 5.5 gives me 7.25. Now, folks, I have intentionally goofed here, so see if you can figure out where I done goofed. If you're looking at this going, each of those numbers looked right, I watched her get those on the calculator. What is wrong with this is we are missing that 0.5 out in front of the parentheses. So again, folks, a lot of the times your base of your rectangles will just be 1. So then you're just going to be distributing 1 to all that stuff to get that stuff. But when it's 0.5, it's really, really important that you don't forget to carry that down with your work. So just be careful about that as you are working on this part of the chapter. So going back to my home screen, I'm going to do 0.5 times the sum of 6 plus 5.25 plus 5 plus 5.25 plus 6 plus 7.25. And that gives me this nasty little decimal. And folks, I am not going to round it. Yes, this is an approximation. It is already inexact, but these were exact values from the function. So we are going to leave this as an exact value. So our LRAM is equal to 17.375 units squared, since it is area. All right, folks, so moving on to the next problem. On this one, we are going to be finding RRAM. So I encourage you to pause the video and see if you can do that first step of using the interval to break it up using the number of rectangles and figure out what your base will be. So go ahead and give that a shot. I'm going to go ahead and darken my function. So on this problem, we are using 4 rectangles. Our function is this icky looking thing. And then on the interval, 1 to 5. So I'm going to go ahead and label the interval. There's 1, there's 2, there's 3, there's 4, there's 5. So if I'm looking at this interval, and if we said, well, how many rectangles would we have if we made each of those bases 1? We would have 1, 2, 3, 4 rectangles. Sweet, that's exactly what we need. So that means our base for each of those rectangles will just be 1. And the height is going to come from our function. F of x equals x minus 2 cubed over 4 plus 2. So go ahead and type that equation on into your calculator. And now we are going to draw our RRAM. So starting from the first interval up to the function, draw a dot on the function. Up from the interval, make a dot. The interval, make a dot. Make a dot. Make a dot. All right, folks. So I would go ahead and pause the video and see if you can draw RRAM, starting at the rightmost point with making your rectangle heights. So start at the right, make your height, color down. This next point is our height, color down. This point is our height, color down. This point is our height, color down. So on this problem, our rectangles are over the curve the whole time. So now that we have drawn RRAM, we are ready to write out our work for how to calculate RRAM. Our base is going to be 1, and then times the sum of the heights. So our first height comes from this point. So this one's a little bit tricky to see. This is why picking up on that pattern that one of your endpoints always gets left off is important. This point would actually be a height like this, which is not the rectangle we have drawn. So our first height actually comes from this point, which would be f of 2. Our next rectangle height comes from this point, which would be f of 3. Our next height comes from this point, so f of 4. Our next rectangle comes from this height, which would be f of 5. So using either your trace button or your table, see if you can find each of those rectangle heights. This would be 1 times 8.75 plus 4. Oops, sorry, I have those mixed up. Ignore that. F of 2 is 2. F of 3 is 2.25. F of 4 is 4. And then F of 5 is, there's the 8.75. And folks, the order that you have these written doesn't actually matter. I normally go from left to right with my heights, but you could have f of 5, f of 4, f of 3, and f of 2. That does not matter to me. So then we take 2 plus 2.25 plus 4 plus 8.75. And we get, woo, straight up 17 units squared. All right, folks, so on to the last page of notes for this chapter. Here is what I would like you to do. Before you watch the next video, I would like you to try these two problems entirely on your own. So on this first one, I want you to find LRAM. On the second one, I want you to find RRAM. You are going to be following the same instructions up at the top for both of those problems. So using for rectangles and on the interval 1 to 3. So try these two problems on your own, and I'll be walking through them in the next video.